Welcome once again to exam focus tutorial. If today is your first time of joining us and you are enjoying our content, try to follow us here on Facebook. If you're on Facebook, like and comment. If you are watching us on YouTube, try to subscribe, like and also comment. The reason why you need to subscribe is so that you can get notified when there are future uploads. Then take note, if you have questions in the comment sections and you have areas you want us to work on the area, comment section, if you want us to solve a particular topic, questions on topics, you can get across to us through the comment section. Now let's get started. We're going to be looking at set theory. Now the subject of the set theory is a major topic in mathematics. The name of the mathematician who is said to be the originator of set theory is George Cantor. This was in 1845 to 1918. I said George Cantor. George Cantor. George Cantor. Cantor is C-A-N-T-O-R. C-A-N-T-O-R. George Cantor. In the year 1845 to 1918. And so there are facts about set we'll look at, but let's quickly look at definition of set. Set is a collection of well-defined objects called element. It's a collection of well-defined objects called elements or member. So take note of the word collection, well-defined. So if objects are not well defined, we can't call it set. For example, you have your knife, your fork, your spoon. All these are known as cutlery. So we can say that cutlery is a set because it contains well-defined objects. For example, you have your necklace, your hand chain, your neck chain, you have your bangles, your rings, your watch. All that have a well-defined name and it's a collection, so we call that jewelry. So jewelry is a set because it contains well-defined elements. So we said a set is a collection of well-defined objects called element or member. Now set is usually denoted by capital letter, take note, A, B, C and so on and so forth, while the elements are denoted by small letters. E.g., if you look carefully here, given that the set is called jewelry, so we use J to represent the capital letter representing the set, and the elements means the thing contained in the set. Look at the elements, the members of the set, we say they are, look at them written with small letter. Now another thing you have to take note of is, note in listing the element of a set, no member is repeated in a set. No member is what? Repeated in a set. Take note. Now we're going to be looking at set notations and symbols. Set what? Notations and symbols. The first symbol here is belong to. Is an element of, is a member of. So anywhere you see this sign, this particular sign, this sign, it depicts what or denotes belong to. Is an element of, is a member of. Take note, like now if you have A is a member of what? B is an element of B, belongs to B. Then you have this with this stroke, it means does not belong to, is not an element of, is not a member. So if you take note, this is opposite of this. The first notation is an opposite of the second notation. Then we'll go quickly to the third notation. We have A union B. This is A union B, union of a set A and B. Look at it, means bringing A and B, all the elements in A and B together. For example, we say marriage is the union of man and woman coming together. So that is how it is. So that is how it is as well. A union, look at it, A union B. We have another one, A intersection B. What does intersection? If you are a mathematician, you remember that the point of intersection is simply the meeting points of two or more straight line. So the meeting point. So now A intersection B simply implies what the common parts where the both sets have common elements. So if you are comparing two sets, do they have something in common? So intersection has to do with common element. They have common elements. So let's look at A, B, C, and we have 2A, 4, 5. So if you look carefully here in set A and set B, what is common is A. So A intersection B is what? A. Let's quickly look at the next notation and symbol. We have this that look like U, a very big U. It is called universal set. Universal set means the mother set. We call it mother set, or the set of the set under consideration. Then we have this. You can see this. This means empty or null set. This is how we explain empty or null set. How do you explain this? You use a curly bracket, empty curly bracket. This is called curly bracket, but you see that it's empty. There's no element inside. It means empty or null set. When a set does not contain any element, it is referred to as empty or null set. For example, you have a can that contains nothing. You say it's empty. That's how the language is here also. So we'll quickly go to the next one. This is called power set. This power set. Power set simply means the number of cardinalities of a set. For example, now if you look here, power set is denoted by 2 raised to the power of s. This s represents cardinality, the number of elements contained in a set. For example, now e.g. we have a set A. Look at the element contain 1, 2, 3. That means our s representing our cardinality is going to be 3. 1, 2, 3. There are 3 elements. We're going to be saying 2 raised to the power of that 3 elements. So if there are 5 elements, you're going to be saying 2 raised to the power 5. So since we have 3 elements, which is going to be s is 3, so it's 2 raised to the power 3, which is 8. It means you can arrange this A, B, C in 3 places. You can scatter it into what? 8 places. For those of you that did permutation and combination, you understand if you permutate and combine, this is what the result you're going to have. Let's count 1, which is an empty set, 2, A. Look at it, 3, 4, 5, 6, 7, and what? 8. So if you look carefully, the next symbol for set inclusion. Set what? Inclusion. We have a set what? Inclusion. Then we have this other symbol, imply, which means implies that. The next symbol is implies and is implied by. We have another symbol, a conjunction denoting and. Then we have another one turned upside down like V, a disjunction. Why the one turning up is conjunction. Take note, this one is what? A disjunction denoting either or both. Then we have another one, A minus B, which is difference of A and B with respect to A, with respect to the first alphabet, which is what? A. Then look at it, B minus A is different between A and B with respect to the first alphabet. What is the first alphabet we have here? We have P. So we said that difference of A and B with respect to B. Then A complement, this little dotted value here like 1 is known as what? Complement. A complement simply means your universal set minus what you the elements of A will give you complement of A. Then we have cardinality. Cardinality means number of elements in a given set. So if you look carefully, it's denoted by n open bracket x. Cardinality of A, number of elements. So it means number of elements. Let's take example. Now, example, we have A, B, C, D, E. Now let's count it 1, 2, 3, 4, 5. So the cardinality, which is ns, equals to what? 5. Now number of elements. Then quickly, we'll go to the next one. We have A delta B. A delta what? B, which means symmetric difference between A and B. Symmetric what? Symmetrically what? Difference between A and B. Take note, we are just showing you all these symbols to help you understand set. In case you meet all these symbols in set, you will not be confused. Please make sure you save this video. If possible, you are using Facebook, you can download this video on Facebook. Keep it, get across to your young ones, because the contents you are getting here, they will be helpful for those of you that are studying set in secondary school and even at the higher level. You discover that there's a notation. Once you have idea of your notation, you'll be able to interpret set question. Now take note, if you have not yet subscribed, try to subscribe so that you get wonderful content like this. So we have that this is such that. Once you see this line, it means what? Such that. For example, if you have S, this statement here simply means S such that S. S such that X. That's what this thing means now. So we have such that. Then this means subset. Subset. Then we have not equal to. Anytime you see equal line and they cross it, it means not equal to. Then we have 3 lines like this, we'll call it congruent. Another word for congruent is equivalent. So when you see 3 equal lines standing, we call it equivalent or congruent. Then we have a symbol like A turn upside down, if you look carefully, that is A turn upside down, it means for all. And we have K carrying something like 1, which is known as complement, or K6, denoted by K raised to power I or K raised to power C, which is for what? Complement. So look carefully and get the symbols, master them, study them critically. We're going to be looking at notable definitions and operations on set. The first one we're going to be looking at is universal set. Universal set, it is a set of all elements to be considered. This is usually denoted by this sign here, meaning entirely, and this sign here meaning universe. So take note, this is the sign for universal set. We also call it model set because it's the main set we need to study and work on. So we call it set under consideration. Then we have number 2, we have what we call subset. We call it children's set. A set is called a subset of another set if and only if every element of set A is an element of set B. It's like a child. For example, a family is made up of father, mother, and children. So the children are a subset of that family. The father is a subset of that family. The mother is a subset. When we say subset, we are talking about part of. So if we say subset, it's called a subset of another set if and only if every element of set A is an element of set B. That is, a subset is gotten from a universal set. E.g., this is a set now. A, B, C, D, E, F, G, and B equals A, C, E. Now, therefore, B is a subset of A. How do we know? Some of the values here, if you watch carefully, some of the values here in A are in B. So B is part of what? A. Because all elements of B is contained in set A. Another example, let's look at this example here. Let's look at this example now. Another example, we have 1, 2, 3, 4, 5, 6, 7, 8 to 9, and they go even to 10. If you look very well, they ask you to look for even number between 1 to 10, odd number between 1 to 10, prime number between 1 to 10. Let's look at it quickly. Okay, note, if you look carefully, you discover that B, C, and D are all subset of A. Why? If you look at this number, there are odd even numbers here, there are odd number, and there are prime numbers here if you select them out. So B, C, and D are all part of what? Set A. So note that set B, C, and D are all what? Subset of what? A. They are part of A. The next one we are looking at is called empty set. A set with no element or member is known as empty set or null set, denoted by this symbol or this curly bracket that is empty. There's no element inside the curly bracket. We call it curly bracket. Note, empty set is a subset of every set. Take note, a subset is a set of every what? Is a subset of every set. That is to say, anytime you are mentioning part of any set, empty or null set is part of it. It's always a subset, it's always a part. Now, example, month whose name begin with what? Q. Is there any month whose name begin with letter Q? No. So that means it's an empty set. We have number 4. Number 4 is called equal set. Number 4 is called what? Equal set. Sets are equal when they have exactly the same element or member. Sets are said to be equal if they have what? When they have exactly the same element or members. E.g., look at the set A containing John, Mark, Steve, and B containing Mark, Steve, John. So if you take note, the name in set A is the same name in set B. The only difference is the order of arrangement, and order of arrangement immaterial. You will discover that set A is equal to what? Set B. Set A is equal to what? Set B. The order in which the elements are listed is what? Immaterial. Take note, is what? Immaterial. Okay, the next one is equivalent set. Now we just finished talking about equal set. What is the difference between equal set and equivalent set? Let's define. Sets are equivalent when they have the same number of elements. Now take note, what the other one say, when they have the same elements. Then they have the same element. So the same what? Element. But this one must be the same number of element, not just the same element but the same number of elements. We can say they are equivalent. For example, now take example, this set A having 1 2 3 4. Let's count set B 1 2 3 4. So set A and B can be said to be what? Equivalent set, because they contain the same number of what? Element. Look at it, A is equivalent to B because of the cardinality, which is 4. They have the same cardinality. Look at it, cardinality means number of elements in a set. 1 2 3 4, 1 2 3 4. Okay, the next set we are talking about is singleton set. This is a set that contains just one element or member, e.g. example is the president of Nigeria, the principal of your school, the governor of your state. We just have one. So any set that contains one element is called singleton set. If you look carefully, where the word singleton is derived from single, then thing. Take no single thing. So that is singleton. So this is a set that contains just one element or member. Or the president in Nigeria. We have what? One president in Nigeria. The president of Nigeria is one. Then we have another set called the power set. Power set. What is a power set? This is the collection of all the subsets of a given set, denoted by 2 raised to power set and x. The example is A is equals to 1 2 3 4 are the elements in this set. So what you do, you say power set A equals to 2. You count all the values inside. You count them. Let's count 1 2 3 4. That is 2 raised to power 4. Take note, it's not 2 raised to power 5. It's 2 raised to power what? 4. This is 2 raised to power what? 4. So 2 raised to power what? 4. Where S, remember in our formula we say is 2 raised to power S. Look at our formula, 2 raised to power S. So S is what? 4. Number of cardinality. Let's count 1 2 3 4. So let's put into our formula 2 raised to power 4, which is equals to what? 16. Look at the cardinality splitted down. If you watch carefully, it has been splitted. Cardinality means how many times can you arrange this? When you arrange it, you're going to have 16 times. So when you work on that, altogether you're going to have 16 subsets. Look at it under that one particular set we just did now. That will give you the cardinality. Okay, the next one is finite set. What is finite set? These are countable set, e.g. all the state governor in Nigeria, you can count them. That's finite set. We have infinite set. You know what they say infinite? It means these are uncountable set, e.g. all natural or counting number. You can't count all the numbers on it. Then we have disjoint set. Two sets S and Y are said to be disjoint when they have no element in common. So disjointed set will give you a null set when they have nothing in common. Please remember, if you have not subscribed, try to subscribe. Now at this point, if you're a university student, pick up your pen. If you're a secondary school child, SS1 2 to 3. Let's solve these questions together. Given a universal set, look at it, all counting numbers 1 to 15. Look, the subset, these are the subset S, Y, Z, A, B, C. What is the subset? First subset, S says even numbers between 1 to 15. Let's check them. What are not even numbers between 1 to 15? Let's go. 2, 4, 6, 8, 10, 12, 14. Then subset Y said odd numbers. Remember, we are checking between 1 to 15. Right? Odd number 1, 3, 5, 7, 9, 11, 13, 15. Prime number. What are prime numbers? We said that prime numbers are numbers that are only divisible by itself and 1. It means it's a number that has 2 factors, only 1 and itself. So let's bring them out from between 1 to 15. What are prime factors there? Prime numbers 2, 3, 5, 7, 11, 13. Those are the prime numbers there. Then multiples of 3. Multiples of 3 is a consistent and sequential addition of 3. So which is 3, 6, 9, 12, 15. So these are multiple of 3 between 1 to 15. Then we have multiples of 5, which are counting in 5, which is 5, 10, 15. Multiples of 4, which is 1, 2, 3. They are just 3. As you can see, multiples of 4 now between 1 to 15 is 3. So on the same question, I want to look at the cardinality of the equation. We have done the first one. Let's look at the cardinality. We have written out the point. What is the cardinality of S? Cardinality of S is the number of elements containing S. So let's go back to X. this is, let's count all the elements. 1 2 3 4 5 6 7. That's why you have 7. Cardinality of y means all the elements containing y. 1 2 3 4 5 6 7 8. That's why you have 8. Cardinality means number of elements in set subset y. Then go again, cardinality again of z, meaning all the number contained in z. Prime numbers, let's go between 1 to 15. 1 2 3 4 5 6. That is why you have this 6. Complement of set. Let's look at complement. What is the complement of set? We said the complement of set is to remove the set from the universal set. So let's look up. If you look carefully, this is complement of s, meaning remove s from the universal set. So subtract all the values of s, remove all even number between 1 to 15, remove it. Whatever is left becomes our what? Our s. Now if you remove even number, or the even number between 1 to 15, what will be left is odd number. Just look at it. Those are the value you have there. Universal set in complement y is universal set minus y. Your universal set, what are the values there? One number 1 to 15. Remove the what? Remove the values of y from what? Your universal set. Remove the elements. And what you have left is your answer. So if you remove even number, now look at the second one, an odd number. If you remove odd number, you have what? Even number. It's like saying universal set minus even number. So when you remove odd number, rather, you have even number. So the same thing goes on here and here. So let's go to the next one. Union of a set. I say union means bringing the elements of these two or more sets together. So this is S union Z. What are the values of S? If you go back, what is common in S? What is in S that is in Y? That okay, we need to combine together. So we need to combine. Union has to do with combination of both sets. So let's look at, we are combining even number to odd number. It will give us our original what? Give us our original value. So you have one. Look at it. It will be S union Z. S union Z. Where is X? Union Z. You add S to Z. You discover that some. It will be, you collect the numbers here and make sure they are not the same. And so make sure there's no repetition. That's what you do. So that is union. Bring out the element of both sets and put them together. So S union B means bring out all the elements in S and bring out the element in B and put them together. So the next one is intersection. I said intersection is opposite of what? Of this particular word union. The opposite of union is to bring together. Y intersection is to pick out what is common. So if you look here now, Y intersection Z means where are the values of Z and where are the values of Z, where are the values of Y. What is common between Y? We have that 3, 5, 7, 11 is common. A intersection, S intersection A, what is common between X and A? We see is 2. Then Y intersection A, what is common is 3, 9, and 5. As you can see clearly. Then difference, S minus A is equals to 2, 4, 8, 10, 14. From the same place, we are still doing the same thing. S minus A, this S, or the value of S. You remove A, remove all the multiples of 3. This is what you have left. Then A minus S, A 3, 6, 9, 12 minus S. Remove all the values of S that are in this set A. It will give you all your value. So that is how it is. So this will lead us to power set. It leads us to what? Power set. Take note, we said power set is given by 2 raised to power S. So let's count. What are the cardinalities of S? Let's count. 1, 2, 3, 4, 5, 6, 7, 7. That means it will be 2 raised to power 7. Cardinality of Y. Cardinality of Y is 1, 2, 3, 4, 5, 6, 7, 8. Raised to power 8. Cardinality of Z. Cardinality of Z is 1, 2, 3, 4, 5, 6, which is raised to power 6. Then cardinality of A. Cardinality of A is multiples of 3, which is 1, 2, 3, 4, 5, which is raised to the power of 5. Hope it's clear. If you're enjoying our content, please like, subscribe, share this video. Don't just watch it alone. If you're on Facebook, still follow us, like and comment on the comment box. Now, this is, if you have any question over this, we just did an introduction to what set. Remember, I said one of the name of the mathematician who is said to be the originator of set is George Canton in 1845 to 1918. Please keep that in the back of your mind.